Hello everyone, this is Dr. E, and for today we're going to be working on the two postulates in triangle congruency, the SSS and the SAS postulates. We have many ways on how we can prove that two triangles are congruent to each other, and for today we're going to be using the SSS and the SAS postulates to test whether the two triangles that we are seeing are indeed congruent. So what are those postulates? So let's start with the side-side-side postulates, or SSS postulate, which means that if the three sides of one triangle are congruent to the three sides of another triangle, then the two triangles are congruent. So from this diagram, we are seeing that triangle ABC and triangle DEF, they have congruent sides that are corresponding. So AB is corresponding to DE, and they happen to be congruent because we are seeing one marking on their side. And BC is also congruent to EF, and AC is also congruent to DF because of the markings that we are seeing. So when this happens, we can conclude that triangle ABC is congruent to triangle DEF because their corresponding sides are all congruent. So let's see if we can use this postulate in proving that what we are seeing in our triangles or two triangles in this diagram are congruent. So here we are given that AB is congruent to CD and AC is congruent to BD, and we need to prove that triangle ABC is congruent to triangle DCB. So to start with, of course, let's draw our little quadrilateral right here, and this is quadrilateral A, B, C, D. This is C and this is D, and we have a diagonal so that we can have two triangles in our diagram. So the first statement will establish the given information, and we know that AB is congruent to CD. So AB, or line segment AB, is congruent to line segment CD. And another information that we have is that AC is congruent to BD. So we can write AC is congruent to BD. And we know that because these are the given information. And since we know that they are given, we are also seeing that we can now use this line right here, this line segment, because this line segment is common to these two triangles. So from here, we can now start with our second line, which is CB is congruent to CB by the reflexive property. And we use this reason and this statement because line segment CB is the common line segment for triangle 1 and triangle 2. So this is how we are using our two-column proof to prove that those two triangles are congruent, and we're able to write CB is congruent to CB because that is the common line that they share for the two triangles that we are seeing in our diagram. So we use this statement due to the reflexive property of congruence that we know from our theorems in a triangle. And now that we know that CB is equal to CB, this only means that if we separate these two triangles, let's say this is separated. So we are seeing that now this diagonal, kind of like a sandwich, is also congruent, and we're able to now show that we can use the S congruency because we have three corresponding sides that are congruent in our triangle. So in this case, we now know that triangle ABC is congruent to triangle DCB because of the side-side-side postulate. And this is how we use our proof to be able to understand how the two-column proof works in this particular diagram. So triangle ABC is now congruent to DCB because the two triangles share the same sides that are congruent, which is the hypotenuse, if we are going to see it that way. So now we have this side and this side that is congruent and corresponding, this side and this side that is congruent and also corresponding, and the diagonal is basically the two lines CB and CB that are also congruent, and they share it with those two triangles. So SSS postulate is what we use to prove that these two triangles are congruent. And now for the second postulate that we are using, the side angle side postulate, it states that the two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. And when we say included, that means that they are connected to each other. So AB and angle A are included because AB is somehow connected to angle A because they share this side right here on this angle. So we know that if we have AB and ED, which happens to be congruent and also corresponding, and we have angle A and angle D that are also congruent, which also happens to be corresponding, and line segment AC and DF that are also congruent and also corresponding, using the side angle side postulate, the two triangles are now proven to be congruent. So let's use that theorem or postulate to prove that triangle ABE is congruent to triangle BCD or CBD. And to be able to do that, just like what we did from our previous example, we're going to start with the two-column proof, and we're going to write the given information that we have from these triangles. And you're seeing two triangles just like how I see it. So I have this triangle, two triangles. We name it A, B, E, and B, C, D. And from the first information, we know that AB is congruent to BC, so we'll write it down. AB, or line segment AB, is congruent to line segment BC, so this is B. And also, line segment EB is congruent to line segment BD. So let's write it down as line segment EB is congruent to line segment BD. And we know that because it's given in our diagram. And we need to prove that triangle A and triangle B are congruent. And we know that we are seeing a special type of angle here. And we know that that angle is what we call as the vertical angle. So from here, we can say that angle 1 and angle 2 are congruent because they are vertical. So we can write it on our second line that angle 1 is congruent to angle 2 because of the vertical angle theorem or angles theorem. And we know that because it forms a vertical angle. And from here, we can now state that we have side, side, angle, angle, and this side to be corresponding and congruent. So now we can say that triangle ABE is congruent to triangle CBD because of the SAS postulate. And this is how we're able to use the theorems that we know to be able to prove that two triangles are congruent, and we're able to do that using the SAS postulate. So the first line is the given information that we have, and the second line we're able to produce or use the vertical angle theorem for angle 1 and 2 because we know that it forms a vertical angles, and we know that vertical angles, they share the same size and same measurement, so they are congruent. And lastly, we now have the side angle side postulate to use because we have corresponding sides that are congruent. So we know that this triangle and the second triangle are congruent because this side is congruent to the corresponding side of the second triangle. This angle is also congruent because of the vertical angle theorem. And this side is also congruent to its corresponding side. Therefore, SAS postulate has now been satisfied. So this is important for the two-column proof that we are understanding those theorems that we are using in geometry to be able to write our two-column proof similar to what we just did. Now that we know how to use our postulates, let's identify congruent triangles based on their given angles and sides. So here we are seeing that this side is congruent to this side of this triangle. So we can mark that these sides are congruent and also corresponding. The included angle, which is 110 degrees, are also included on the other triangle. So therefore, those angles are congruent and also corresponding. And the 10 millimeter side right here would be corresponding and also congruent. So we are seeing SAS in our triangles, which means these two triangles are congruent using the SAS postulate, because to prove the triangles are congruent, since the two pairs of corresponding sides are congruent and their included angles are congruent, we can say that triangle 1 or triangle A is congruent to triangle B. Next triangle, let's have triangle 1 and triangle 2, and let's see its corresponding sides and angle if they are congruent. So this is our side and this is the other side, and they are corresponding and also congruent. This is our angle and this is the second angle, which are also corresponding and congruent. However, we are seeing that for this particular side, on the other triangle, however, that side is congruent to this side, but the problem is it's not included with these two items that we have on the second triangle. And with this, we cannot say that triangle 1 is congruent to triangle 2 because we cannot use the SAS postulate in this particular triangle. So this is why it's important that you are recognizing the included parts of our given triangle to be able to identify the postulates that would work for its congruency. So let's see if we can use that in this third example. So we have two triangles that are next to each other, and we know that this side is congruent to the other side, and they are corresponding. And this side is also congruent to its opposite side, which is also corresponding. And now we just need another item to see that they are congruent so that we can use the SSS postulate. And in this case, we can because they share the same side. Because if we separate these two triangles, we are seeing visually that they are indeed congruent because their last or this leg right here or side are congruent to triangle 1 and triangle 2. So using the SSS postulate, we can say that we have proven that the triangles are congruent because the three pairs of corresponding sides are congruent because the triangles share a common side. So that's how we use the SSS and the SAS postulates to prove that two triangles are indeed congruent. So for your number bender challenge for the day, let's see if you can prove that triangle 1 and triangle 2 are congruent using the postulates that we have just used for today. So comment it down below and see. Let's see the reasons that you can formulate for triangle 1 and triangle 2 to be congruent. And this is our lesson on congruency on triangles, and in proving that triangles are congruent, we don't need to show that every single side and every single angle of triangle 1 is congruent to triangle 2. All we need to have are three items, either the side, 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 or the side, angle, side, to show that the two triangles that we have are congruent. So practice is what it takes for you to be more confident in writing two-column proof, just like what we had today. This is Dr. E, and see you again next time. Bye!